let's solve the section 1-B and 1-A. So from 1-A to 1-B. So I'm going to put here section, so it will be 1-A to 1-B. Okay, so we go to pipe. Okay, then we have your volume flow rate, which is how much? That one is 45.43 GPM. So we have 45.43 GPM. This is equal to 2.87 liters per second. Okay, so let's solve the Reynolds number for this call it pipe. So okay, then we have, so we have been substituting na the value. Okay, so kulang tayo ng velocity. So we can solve your velocity from your putting it to equation. So that will be Q is equal to your area times your velocity. Then we have your velocity, that will be Q divided by your area. So yung Q natin, so that is for this, how much is that one? 45.43 or 2.87 liters per second. So it will be 2.87 liter per second. So we change that one to 1 cubic meter. So you have 1000 liters. Then divided by your area, so that will be pi over 4. Then the diameter, which is 26.6, so this will be 26.6 mm. So divided by 1000 to make it meter, so raised to squared. So we have now your velocity is equal to, so we have the velocity of 5.16 meter per second. Right? So let's input that value, that's 5.16. And this is 1-inch pipe. Then this one is also, we have the same, also 26.6. Then the velocity, sorry, this is 5.16. So this is 5.16. So let's erase this one. Okay. Then the Reynolds number, okay, yun ang kulang natin. So and also the viscosity, so that will be same temperature. So it's also the same, 0.00105. And the pipe length, it will be how much? That is 1.61 meters. Put here 1.61 meters. Then okay, so let's go to compute the Reynolds number, no? So we have the velocity, which is 5.16 meters per second, and it will be divided by, so the viscosity, which is 0.00 point, it will be 0.00105. So this will be Pascal second. Let me mistaken, it is Pascal second. So then we have now the value of your Reynolds number. So we have, it will be 130,471.63. So inputting that one is 130,471. So still it is turbulent flow. Okay. Then we have change in elevation, so it will be 0. Then the density is the same also, which is 998.91. So specific weight, it will be 9,799.3. So friction factor, okay, so let's go to the Moody's diagram. Okay, so we have now here the Moody's diagram. So relative roughness mo, so since it is 1 inch pi, so it's the same also tulad ng kanina. What we do is, what we have nandito ba, relative roughness is not shown here, but we can, so repairing yung kanina, since it is 1 inch pa rin yung tubo natin, so repairing yung last time solution natin, we have 0.005 yung relative roughness. Okay, so going back, it will be 0.005. So we have putting it here, so that will be 0.005. So this has a 30, so 0.5. Then we have here the value of Reynolds number is 130. That will be 1.3 to the power of 5. So starting from here, you have 5. Okay, so this is already 1. So it will be 1.3. So this is 2. This is 10, and this is 1. So somewhere we're gonna draw a shape here, line. So somewhere it is here, 1.3. Okay, passing. Then you have your relative roughness going here. Okay, so we ito tayo mag-intersect somewhere here. Then we draw a line. Then we are going here. So we have the value of this is 5, 6, 7, 8. So it will be 0.018. So we have now the friction factor 0.0. So it will be 0.018. Okay, so we have the value now. So again, computing the values of here. Okay, so since we have your HF now, so let's compute now for the pressure loss kanina, so we can use that one. So we have your equations. So we have change in elevation will be 0. So we have change 0 elevation, and also the velocity, the diameter is also the same. D1 and to D2 are the same, so it will be 0 out. So we have now pressure 1 dash A to pressure 1 dash B is equal to specific weight multiplied by the HF value, where our HF, so it can be specific weight, that will be HF, so that will become F is equal to L over D squared over 2G. We can specify this one where your specific weight so we have now we have your diameter. Okay, so we have the diameter now, then we're going to multiply this one to the so that will be B squared, no? Okay, so we have your velocity, which is 5.16 meter per second. So you have here squared, then divided by 2 times 9.81. So okay, then finally we have the value. And we have the value of, so this is 14,487.68. so we have Newton per square meter. So inputting that one in our table, so it will be 14,487.7. so we round it up, so round up na lang natin. Okay, so then let's go to fittings naman. What we have here, fittings, so we have here your T papunta doon. Okay. So for your fittings, so that is we have your T or T branch. So let's put this one, T branch. So we have here your T. Then also 2.87. Then we have 45.43. Then Reynolds number is 130,471. So we have your turbulent flow. So size is 1 inch. Then also here is 26.6. Viscosity is 0.00105. Velocity is 5.16. The pipe length, so blank. Change elevation is blank. And the same also value, we have 998.91 and 9,799.3. Then your KL, friction factor, we have here, so that is plunge, or we have threaded, that is 2. We put it here, 2. Okay, 2.0. Then finally we have the value, so we can solve now the value for that one. So so that will be for that one, it will be for that section, it will be P1 dash A, sorry, that is P1 dash 11 dash A to P1 dash B. So that is equal to friction loss. We have this specific weight, so multiply by KL times b squared over 2g. So we have your specific weight, which is 9,799. So it will be Newton per cubic meter. Then multiply by the KL, which is 2.0. Okay. It's 2.0 with the velocity of 5.16. So we have velocity of 5.16 meter per second squared divided by 2 times 9.81 meter per second squared. Then we have now the value. So we get the value of 26,595.74. So we have Newton per square meter. So plug natin doon sa table. So it will be 26,595.7. So we have the value now for that section. Then we go down here later on. So we sum up dito yung cumulative loss. We have loss per section. We have later on we'll do that. Let's go to 1-B to 2. So section 1-B. So we have 1-B to 2. So we have pipe again. So this is now the volume flow rate is 4.13 GPM. We have 4.13 GPM. So that is an equivalent to, so from 1-B to B-2. So we have your pipe again. So ito yan, 1-B to 2. So this is your 2. Punta dito. Okay. So what we have is, so you have the volume flow rate, which is 4.13. So branches na yan. Okay. Then we're going to compute the Reynolds number again to determine the type of flow. So let's plug in, copy this one. So what we need, we have your density, we have also your diameter. Now what we have now, wala tayo, is the velocity of that one. So again, your volume flow rate, we can compute that one. So we have again your Q is equal to your area times your velocity. So that will be yung Q divided by your area. So we have 0.26, that will be liters per second. We multiply it by, and let's convert it to 1 cubic meter is 1 cubic meter is 1,000 liters. Then divided by pi over 4. Then the diameter natin doon ng pipe. So this is already in 1/2 inches. So 16 mm. Okay. So this is nominal niya, we have 1/2 inches. So this is 16.0. So that will be 0.016 meter squared. So we have now the velocity. So we have the velocity of 1.29, or let's say this is round up natin 1.3 meter per second. So let's input that in our table. So we have your velocity, which is 1.3. Then we have again the viscosity is the same, 0.00105. Okay, so we can compute now the Reynolds number. So computing the Reynolds number, so we have your density, which is density of H2O is 9,799. So we have 9,799.3. So this will be kilogram per cubic meter. Then the diameter, we have your 0.016 meter. Then the velocity, which is 1.3 meter per second. So let's divide it by the viscosity, which is, you have 0.00105. So we have Pascal second. So we have now your Reynolds number is equal to, so Reynolds number natin is, we have 193,723.3. So inputting in our table, so tumaas tayo, since mapapansin nyo, value niya is lumaki because nagliit tayo ng 23.3. So this is again a turbulent flow. So we have your pipe length. So we have your pipe length starting from here going here. So we have 5 point, so we can put it 5.2. So pipe length natin is 5.2. 5.2. Change in elevation is 0. Okay, so same properties of water. Then specific also is the same. And friction factor na lang. Okay, so we needed to determine it by means of the using the Moody's diagram. So let's compute pa pala yung relative roughness since the diameter of the pipe changes. So let's compute the relative roughness. Relative roughness. Okay, let's see. Lagay na natin ito. Relative roughness. So that will be yung E divided by the diameter. Okay. So from the table, okay, so steel, galvanized, or corrugated or plain. So we have your design 0.005. Okay, entering that one 0.005. So we have 3 zeros. 0.0005, then divided by the diameter, which is yung inside diameter natin. So referring yung table, okay, so that is 1/2, no? So here we have 1/2. So 1/2 schedule 40. So we have the inside diameter, which is 0.622 inch. So we can use that one. So let's do plug it that one. So that is 0.622. So we have the value. So we have the relative roughness of 0.0008. So let's check this one. So ito yon. Okay. Then our Reynolds number is 193. That is 1 point. So that can be expressed as 1.9 times 10 to the power of 5. So here we have 10. So this is 1.9. So somewhere here, flowing here. So we can draw the shapes here. A line here, starting here. So since it is near to the 2, then you have this one intersecting here. Since it is this one running to 0.008, and this one transverse. Okay. So it is 0.2. We have here 2. So pagitan that is 0.25. That is somewhere 0. So that is 0. So this is 0.02. So this is 1. So that will be pwede na rin siguro. So this can be 0.0 since this is your 1. So this can be 0.5. Okay. So we have your friction factor of 0.0205. Okay. So for solving for the friction since i-by na ito, so let's take it. So again using this equation, so we can cancel out yung na. So since we don't have the change in elevation, so this will become 0. So there is no change in diameter. So since yung pipe natin is running from same pipe na sizes niya, so that is 1 dash B2 plate. So starting from here, okay, so there is no change in so there is no call this reduction of we call this reduction of size. Then so we have now ito na lang may iwan, so we can put it as your equation as, so we have P does 1 does B is equal to P does 2 is equal to this specific weight times your HF. Okay, so HF yung isa, or HF, so this will become yung kanina, so that will be specific weight, which is equal to 9,799. So this will be Newton per cubic meter. Then multiply mo ng value ng F, which is, so that is 0.0205. Then you have the length of the pipe. How much is the length? So we have the length. So we have 5.2 meters. So 5.2 meters divided by the inside diameter, L over D. So we have 16. So this will become 0.016 meter. Then multiply it by the velocity. So velocity is 1.3. So this is 1.3 meter per second. So this is raised also to square, divided by 2 times the gravity, which is 9.81 meter per second squared. Okay, so we have the pressure loss between that pipe is equal to, so we have 5,623.5 Newton per square meter. Okay, so inputting that one here, so we have 5,623.5. So we have 5,623.5. Okay, so we have the value. Okay, so we're going to check how, since we have now computed yung layo niya. Now yung what I'm concerned now is we have T things, no. Yung T ba natin T kanina, okay, nagamit na siya. Then we have here sudden reduction, so nag-reduce tayo. So we going to put here concentric reducer. Okay. So, P things natin, so reduction, so katulad nito, okay. So we have your gradual expansion, so we have your KL then, gradual, so we have gradual contraction. So I'm going to put here, so that is gradual contraction. Okay, so reducer, or we can so very common, we have reducer. So reducer, I'm going to put here reducer. Okay, so this is speeding. Okay, so same value, we have 0.26, 4.13, same Reynolds number, we have 993.723.3, so same also. Turbulent flow, then we have your size, which is now 1/2. Oh, so that is from 1 inches. Sorry, size is 1 inches by 1/2 inches. Reducer, pipe reducer. Then so that will be 26.6 by 16. Okay, so viscosity is the same, so that will be 0.00105. Then we have the velocity, which is now 1.3. Then the pipe length, so this is leave it blank. This is blank. Then we have your density, which is 998.91. Then this is 9799.3. Then we have the friction factor, and so we can get the value for the pressure loss. So contraction, so let's say we'll be using palagi na lang siguro we'll be using 60 degrees. So 45 here. Okay, so we can use 60 degrees na lang palagi. So we'll be using 60 degrees. So 60 degrees, that will K factor, that will be 0.07. So we're putting here 0.07. Okay. Then we can compute the loss now. So it's also here P1 plus B to P2. So for your minor fittings, we have your specific weight times your KL, then multiply by B squared over 2G. So that will be 9,799 Newton per cubic meter, multiply by 0.07. Okay. Then the velocity on the pipe, we have 1.3 meter per second. So this is squared divided by 2 times 9.81 meter per second squared. So let's change this one. Okay. So we have we have 59.08. So this will be Newton per square meter. So we going to input here. So we have on 59.01. Sorry. So this is 59.1 na lang. Okay. So next is we have also from here, you will notice, so we have your reduction, then we have your elbow here. Okay, so you can add that one. So the same also equation KL, so we have a B squared over 2G is equal to, so KL for elbow, so that is 90 degrees elbow, so we're going to categorize it as a threaded, that is 0.9. Okay. So we have 9,799, that would be Newton per cubic meter, times 0.9. Okay, 0.9 tama. 0.9. Then that will be velocity 1.3 meter per second squared divided by 2 times 9.81 meter per second squared. So what we have here now is, so what we have here is 759.64, or let's say 65. So this is Newton per square meter loss. So lagay din natin dito, we have dito na. So 759. So you will see how much ang laki ng loss ng ano, ng elbows. It's 0.65. So we have here elbow. So we have again 0.86, 4.13 volume flow rate, and the Reynolds number is the same. So we have 193.723. So again, turbulent flow. So we have the size, which is 1/2 inches. That is 16. And the viscosity is the same, which is 0.00105. Then you have your velocity is 1.3. Okay, the pipeline blank, change in elevation blank, we have 998.91. And also we have 9,799.3. Then this is friction factor, that will be 0.9. Okay. So we have now elbow. Okay, so